Hello ChemComm. Today we're going to finish up talking about combustion in fossil fuels by talking about ways we can alter those fuels to make them more efficient. Let's get started. Typically, in a barrel of crude oil, only about 18% is naturally occurring gasoline. Because gasoline is one of the most sought after compounds in our society, we can take some other compounds in that barrel of crude oil and use some chemical processes in order to make gasoline out of those things. This can make it so almost 47% of that barrel of crude oil can be used for gasoline. One of the most common things we can do is called cracking. This takes very long hydrogen and carbon chains and cracks them or breaks them in half. Gasoline compounds are only about 5 to 12 carbons long. So for instance, we could take something like decane and we can crack it in half and make propene and heptane. The heptane can be used for gasoline compounds and the propene can be used for other industrial processes. It could be saturated with hydrogen to make propane. Something that might be used during this process is called a catalyst. A catalyst chemically speeds up the reaction, or it could lower the temperature that the reaction needs to take place at. Whenever you crack a hydrocarbon, typically you need really high temperatures, but we can add a catalyst which actually lowers the temperature of that cracking process and makes it happen more efficiently. This is also helpful because it requires less energy to help make these compounds. So as we've already said, we can take large hydrocarbon chains, like if they're 16 carbons long, and we can crack that in half to two 8-carbon chains. And gasoline typically needs carbon chains in that C5 to C12 range. One way we rate gasoline is through an octane rating. Gasoline is mostly made from straight chain alkanes, but these burn very quickly, and if they burn too quickly or they prematurely burn before they get into the piston chamber, the engine will start pinging or knocking. One way to prevent this is to mix in branched chain alkanes, and that limits some of that knock, because it takes the branched alkane a little longer to ignite and burn. We give gasolines octane ratings. The higher the octane rating, the more efficient the gasoline will burn, and they typically don't knock as much. When you go to a gas pump, you see 85, 87, and 91 octane gasoline. Prior to the 1970s, one thing we did to increase the octane rating was to add tetraethyl lead. This is a compound that has lead in it, and now we know that lead is horrible for the atmosphere and for the environment. So the government requires that all lead is removed from gasoline, and that's why we have unleaded gas. We had to develop other ways to get anti-knocking gasoline instead of putting these lead compounds in there. This chart shows gasoline and some of the things we blend with gasoline to improve octane ratings. So if you look at a basic gasoline, its octane rating is about 84. A lot of times when you go to the gas pump, you'll see 85, 87, 91. So what we do is we blend things with that 84 rated gasoline in order to raise the octane and make it a more quality efficient gasoline. One of the things we mix with it is ethanol. You can see ethanol in this chart has an octane rating of 114. Ethanol is super efficient and it's often blended into gasoline. We now have cars that run on E85, which is 85% ethanol. It's a very efficient fuel and it typically has less emissions. There's other things we can mix into gasoline like butane and MTBE, which all help improve the efficiency rating of gasoline. Another thing we can do is add oxygen to the fuels. Fuels need oxygen to burn, and if there's oxygen already integrated, these fuels will burn more efficiently. They produce less energy, but because they burn more efficiently, there's less byproducts that can get into the atmosphere, which makes it better for the environment. One way we can add oxygen is by increasing methanol. Methanol is a hydrocarbon that has an alcohol OH group on the end, and that OH group adds oxygen into the gasoline. It's also easy to make. We can make it from natural gas or coal or even wood. Another oxygen-based hydrocarbon is ethanol. This looks very similar to methanol, but instead of one carbon, there's 2 carbons, and we still have the oxygen integrated in. As we said before, we talked about ethanol being super efficient, having a very high octane rating. The last additive we can put into gasoline is MTBE, methyl tertiary butyl ether. This has a very high octane rating and it can make very efficient gasoline. The problem with MTBE is that it can seep into the ground and into the groundwater and cause all kinds of environmental and even drinking water problems. It's the most common additive since the 1990s, but there is consideration right now to reduce it or even ban it in our gasolines, which would require us to have to find another way to make our gasolines more efficient. And finally, the last way that we can make gasolines more efficient is to take straight chain alkanes and turn them into branched chain alkanes. We talked earlier about how branched alkanes don't burn as quickly and therefore they knock or ping less in the engine because they don't burn prematurely. The process of making these branched chain alkanes is called isomerization. An isomer has the same number of carbons and hydrogens. We've just rearranged them in a way to create an isomer, a different shape, a branched chain alkane, so that it doesn't burn as quickly. We then take these branched chains, mix them with straight chains, and we boost the octane rating of our gasoline. The one drawback of isomerization is there's a high cost to going through this process, and that high cost can make gasoline more expensive. And those are some different ways we can alter fuels to make them more efficient. As our society continues on, I'm sure that we'll think of more chemicals and more things we can do to make gasoline more efficient. But at the end of the day, the most efficient way to reduce emissions is to convert a combustion engine to an electric engine. Electric engines, even though they have their drawbacks, do not have emissions. These are all issues that you should be informed about as our society kind of wrestles through them over the next few decades. Take a look at the activity for today. Keep up the good work. We'll see you soon.